Hello there, my name is Christian Alfoni and I'm the author of the library Cerebral. And I'm going to introduce Cerebral to you now. And with me I have Yoda. So we're going to use Yoda as like a backdrop to introduce concepts and why Cerebral is what it is. So try to think of Yoda here as an application. And in your application you have views. That's the most important part. And thinking of Yoda and this joke here, we need a finger view, which we are going to interact with. We are going to pull Yoda's finger. And something is going to react to this, and that's a different view. On the other side of Yoda, the butt view, Yoda's butt. So we're going to go through some concepts now, how we communicate between these views, going through some history and up to the point where Cerebral fits in. So one way to inform the butt view that the finger has been pulled is to use imperative programming. And what that means is that the finger view will actually tell the butt view to do its thing. So the way that works is that the finger view actually has a dependency to the butt view, and it calls a method directly on that view. The problem with that is that if you go into the butt view, you have no idea. If you go into that file, you have no idea that there's actually another view calling methods on it. So it's harder to reason about your application. And if you do changes, it's very likely to break. And if we think about this like in a more abstract matter, like in anatomically, if you would pull Yoda's finger, I don't think his anatomy is like the finger tells the butt what to do. That just seems really weird. So let's move on and see if we can make this a bit more natural. So the other way to think about this is to use reactive programming. And now the butt view has a dependency to the finger view. And the butt view listens to a change on the finger view. So the finger just emits an event that it has been pulled, and now any view can listen to that event. So it's a lot easier to scale your application because you don't have to change the finger view every time you want to notify something else about the finger being pulled. So the butt view listens to the finger view, and when it emits, it will trigger its own method. And this works better. As I said, it's easier to scale. But if you want the two of these views to have a relationship with each other, that's a problem, because you very easily get circular dependencies if one view depends on a view that depends on the other view. And if we think about this anatomically again, it is also a bit strange that the butt is listening to Yoda's finger and reacts to that. It just doesn't make sense. So if we move on, we can see a pattern that you're probably familiar with, and that is giving Yoda a brain, something that can control all these events. So what happens here is that both views are able to call a controller layer, which is just an event hub. And that will emit an event. And all the views can listen to the controller and get events back or react to those events. So this is making things a lot better in terms of things going in a loop where things depend on each other. But it's kind of hard to reason about your application because there's not just this one event. You will have insane amounts of events calling each other, and it will be very hard to read this and reason about. Another thing is that this is stateless. So when the view calls the controller and it emits an event, you can pass a value, but there's no state here. So the state is inside each of the views, and if you want both views to have the same state, you have to synchronize this. You have to pass a value from one view to the next, and that view has to store that state. So it's a lot of manual stuff you have to do, and it's really hard to keep control of this. But now we're starting to see that we're getting closer to something that's anatomically correct. And that is that the finger view just says that something pulled my finger, and it notifies the controller about that, and then the controller emits that event. And all the other views can react to that. And that is pretty much how our bodies work. So it's kind of nice to see this, that we can be inspired by this. Moving on, we got Flux. And what Flux basically did, as we go through these patterns here, is that they introduced some state into, like removed the state from the views and allowed us to have state outside our views. We can still have state inside our views, which is called components using React. But we are now kind of allowed to have state outside them, and we can share that state. So in the previous example with the Event Hub, another problem with that is that you cannot get the initial state. Because if you want the initial state from all the views, those views have to depend on each other. And then you get circular dependencies very, very easily. So it's a problem. But in this example, where the finger view tells the controller that now my finger was pulled, now you have to make the butt view do its thing, it goes through a model layer. And that model layer will save a state or change a state in the application. And normally that would be is flatulent, but since this is Yoda, he would say flatulent is. And now the other views of the application are able to react to this state change. So now we can communicate between our views and store our state outside the views. And this works very, very well. Flux kind of solved all the problems I've been talking about up to this point. So personally, I just want to do a shout out to the Facebook people for introducing Flux. It just makes so much sense. But, if we move on here, let's move into this model layer. So the controller layer of Flux is the dispatcher. So a view just triggers a dispatch, and that has a payload which tells what method to run to produce some state. And maybe there's some data there that you want to put inside your model layer. And the controller layer, as I said, is just that dispatcher passing that action into the model layer. And the model layer are stores. You have multiple entities that can take care of some state. And the problem with that is that we start to get this same problem that we had with our views, because these stores actually quickly starts to depend on each other. And when you do a dispatch, one store should do something before the next one. And then you get this wait for method to wait for stores. But that doesn't work too well, because very, very often you have to do something asynchronous, like talking to the server or whatever. So you can't really do that. So our state changing logic is inside these stores, and we quickly get a circular dependency issue, and we can't do async stuff. So that is a problem. But the community started giving feedback on this, and what happened is that we got these action creators. So we moved the logic we normally would do inside the stores, we do inside the controller layer, where it actually gives a bit more sense, because that is where you, like, the state changing logic of your app is like controller. The model layer is just storing state. So what happens now is that the view layer will just call a function in the controller layer, and that function will do async stuff like talking to the server, and it can do multiple dispatches into these stores. Now the problem is that now we have state-changing logic inside our stores, and we also have state-changing logic outside our stores. So it's just harder to reason about all this. But then something happened. We got Baobab. If you don't know that project, it's a state tree. So instead of having multiple entities representing your model layer, you have one single tree. And when you have that tree, you don't need a dispatcher to control the flow into the stores anymore, or into the model layer. It's enough to only have that tree, and it's basically one object containing all the state of your application. So what happens now is that we have this one entity in a model layer, and the controller also becomes this one entity, which basically are those action creators. But instead of creating an action and dispatching them into these stores, it's just a function that can talk to the tree and do changes on the tree. And then the tree will emit change events, which the other view layers can listen to. And this was also a big moment for me. It was, yes, finally, now I understand. Now Flux works the way I want it to work, because less stuff to think about is actually a lot better. So a big shout out to Baobab. Great project, and it was like a milestone in my own personal development as a developer. Yes, but to look at this from a bit further away again, we can see that now we have our views and we have the controller, which is basically a function. And then we have our model layer, which is this single state tree. Now let's take a look at these functions inside our controller. A typical function would be, as we can see here, getUser. The thing is that getUser isn't really just getUser. It does multiple things. It changes to isLoadingState, it does an AJAX request actually getting the user, but then it gets a response and sets the user and changes the loading state again. But if there's an error, it will set an error instead and then undo or set the loading state to false. So this function could be called, should be called getUser setLoading, setLoading getUser setUser if success, or set error if not success, and set loading false, or something. You know, I'm just trying to make a point there. And this is so it's really hard to reason about this function. For once, the name doesn't tell you what it does, and you have to go through the implementation of the function to actually understand what it does. And this is a simple function. This can get crazy complex, and you can call other functions, and you have to like dive into all the code to understand what it actually does. And what we also see now is that we're losing this great concept of the view layer just saying what happened. So with this getUser function, if you were to dive into your controller, you don't know what triggered this. You don't know what happened in the view layer to trigger this getUser function. So that's also not very good at the moment. And this is exactly where Cerebral comes in. It tries to solve this controller area. I feel that now we have a fantastic view layer, and with the single state tree as a model layer, I feel that's been solved too. But we have to do something about this controller layer. It's just too hard to reason about and scale our applications. So let me introduce Cerebral. It's a state controller. So it controls the state changes of your application, and it also has its own debugger. But let's take a look at how this looks from far away. So you still have your view layer, and you have this controller. So the main thing inside your application now, looking away from your view, is the controller. So all the views have the possibility to talk to the controller, and they can listen to the controller to be notified when they should update themselves. And the controller has a dependency to the model layer. So nothing talks to the model layer. It's just something that the controller needs to keep the state of the application and do state changes. So it's really all about the controller. And with Cerebral, you have the possibility to replace the model layer and the view layer. So the view layer can be a React, but it can also be Angular, or I haven't tried it yet, but you can use backbone views if you want to do that. I know it will work, or even jQuery you can use. And for the model layer, you can use Baobab, or I have a project called Immutable Store, and Immutable.js if you want to do that. So let's take a look at this function again. So at the left side, we have this traditional action creator-like function. And on the right side, we have what you would define with Cerebral. So instead of just defining this single function, you define a signal. And this signal needs a name, and the name should be what happened in what part of your view layer triggers this signal. So everything in the view layer will get its own signal, and that will let you read inside the controller what in your view layer caused this signal to trigger, which is really important. And then you use a set of arguments which represents, so it's like an abstraction up from the function on the left side. So you will create a function for set loading, and as we can see, the next argument is an array, and that basically just tells Cerebral that the action inside this array is asynchronous. And the first action we trigger there, we trigger by using a factory. So as you can see, set loading is just referencing a function, but the get function is being called with the user path URL. And that means that it's now very, very easy to do compositions and use factories to return actions and stuff like that. So instead of defining these getting data all over, you could create a factory that just takes an URL, and then you get the action that talks to that specific URL. So that was an example of using factories. The argument after the factory is an object, and this object represents paths. So the action get will actually be able to choose a path depending on it being a success or an error. And then you see what actions are triggered either on success or error. And when this asynchronous stuff inside this array is done, it will run the unset loading function. So instantly you see that it's very easy to read a signal compared to a normal function. So you know what triggered the signal, and you very easily see what happens when this signal is triggered. And this is a very simple state changing flow. And this can get crazy complex, but you still have this really nice abstraction. So you can easily reason about how this signal works. So let's dive into this signal and just see how you would define these actions. So the set loading action is a very typical action, and all actions receives 3 inputs, it being asynchronous or not, where the first argument is input. This is where you get data from like when the signal triggers, you get some data, and you can also get data from previous actions in the flow. So for example, if set loading had an output, both get user, set user, set error, and unset loading could access that output using their own input. The second argument is state, and that is your endpoint, if you like, to your model layer. So state just has a few methods that lets you mutate the state of your application in different ways, like set, push, unshift, pop, all that stuff. And of course also get state from the model layer. And then you have this output, which actually outputs values to the signal. As I said, if you output something, it ends on the signal, so all other actions after it can access that data. If we take a look at the get user action here, we can see that it points to a utils property. So with Cerebral, you can define some default inputs. And these inputs will be added when signals are triggered. And this makes it very easy for you to test these functions. They are completely pure if you look at just the function. You could say a side effect is using state here. But it doesn't matter in regards of testing. So what you would do here is you would pass in a fake input argument and a fake Ajax library. And if you wanted to test the state, you could just fake a set method, for example, and make sure that your action actually does the state changes you want to. But as we also can see in this function is that it's using the output argument. So it just outputs success or outputs error. And then we have set user, which basically works the same way as set loading. But now we are using this input. So the thing is that when get user now has an output success, it will put a user property. It will output a user property with the data. And then there's an action after it that will actually set that data. And the reason it works like that is that when you run asynchronous actions, you can't mutate state. And there's a good reason for that. And that is because instead of replaying your state changes when you debug the application, it will actually replay the signals. And that gives you more information about what's happening in your application, not just the state changes, but actually the flow. And that's the really interesting part with Cerebral. So when you're remembering state and reproducing state, it doesn't actually run these asynchronous actions, but it remembers the result of them. So it will just skip them and pass the result on, and that is why only synchronous actions can do state mutations. So with this mental image in your head now, let's take a look at an application. We are going to take a look at to do MVC here. Let me just reset here. And what we see here now, or what's going to be really interesting, is that you have no idea how I have coded this app. What does the code look like? You have no idea. But when I now start to do changes on this application, you can see that the Cerebral debugger on the right side is now indicating what signal is being triggered, what actions are being run, and what mutations are those actions performing. So if I hit enter here, you can see that we are running a more complex signal where it does all these changes. And this is a really interesting concept. So if you've never ever seen the code of a Cerebral application, you can play around in the UI and you can see how the application flows. And that is what I think is missing today. This is what we have to explore. We have to make it easier for ourselves to reason about how our application works, because if we don't know that, we will have a very hard time fixing bugs, and we will have an even harder time implementing new stuff because we will break all the other stuff. So I can do some more changes here, up for example. And as you can see, I can grab this slider and I can move back in time to verify the state flow. And I can also refresh the application now. And it will actually reproduce the state. And that's a really good thing. So when you do changes to your code and your application refreshes, it will keep that state around, so it's easier to develop. It's also possible to reset, as you saw now, but we can also record. State. So if I hit record now, and I say hep, and stop it, and I can play it back, and now it just honors the time between when the signals trigger. But as you can see, we now have this really powerful stuff. And I remind you again that though you might be using React, you don't have to. You can use other kinds of view layers, and as I also stated, other kinds of model layers. But yeah, this is what I wanted to show you. So thanks for watching, and I hope you can benefit from using Cerebral. Thanks.